You can see the screen right now, right? Can you see the screen? Okay. So this was the last point that we discussed. So which are the different modes of operation in case of MOS capacitor? Which were the different modes of operation? First one was accumulation. I'm just revising the topic. First one is accumulation mode, which is the second mode, of operation of MOS capacitor. Depletion mode, yes, it's depletion mode. Fine. Then you have the third mode, which is called the inversion mode. And finally, you have the strong inversion, which is strong inversion is just a part of the inversion mode itself. So the fourth one is strong inversion. These were the four different modes of operation. And you know the difference between the different energy band diagrams of all these different modes also. We have drawn the different energy band diagrams also. So what is the speciality of voltage, gate voltage, that is VG in these cases? What will be the value of VG in these cases? In one of the case, VG will be less than 0 or VG will be negative value. Which is the case? ഏത് mode of operation ആണ് VG less than 0 ആവുന്നത്? Which is the mode of operation where VG value is less than 0? Yes, accumulation is the mode of operation where you have VG less than 0. You know the figure of MOS capacitor also. It is the metal part. You have the intermediate or central oxide part, and finally you have the semiconductor part. Okay, so this is actually the voltage VG. VG is called gate voltage, and this is the oxide layer, and finally you have the semiconductor part. In our example, we are taking the case of a p-type semiconductor. Okay, this is actually the structure: metal, oxide, semiconductor. In our case, we are taking p-type semiconductor. Okay. So VG will be less. That is the voltage applied over here. That is the voltage applied over here will be negative or less than 0 in case of accumulation mode. That is, this will be negative, like this it will be applied in the case of accumulation mode. And in the case of accumulation mode, what happens is that since we are connecting positive over here, the holes will get repelled towards the intermediate, right? The interface like holes will get repelled, and it forms a layer of holes at the interface between semiconductor and the oxide. Here you will be having a layer of holes formed. Okay, that was called the accumulation of holes, and that particular mode is called accumulation mode. And we have drawn the energy band diagram, and there in that case the band bending was in the opposite direction. Can you tell which is this mode of operation? If this value and this value are equal, which is the mode of operation? ഈ രണ്ട് വാല്യൂസും ഈക്വൽ ആണെങ്കിൽ which is the mode of operation? ഈ വരച്ചിരിക്കുന്നത് ഏത് mode of operation ആണ്? If these two values are same. പറഞ്ഞോ? Yes, this is strong inversion. If I am mentioning that this value, if I am representing, if I am denoting it, you will be having EIB. This will be your EV. This will be your EF. This will be your EC. This will be the Fermi level of metal. And this difference between EF and EFM is given as Q into VG, where VG is the voltage applied. Okay. So this particular figure is not of accumulation. Accumulation figure only working. This is actually of strong inversion. If I'm mentioning like these two values are equal. So in the case of accumulation, you'll be having a different figure that you already know. You have that in your notebook also. And the second was depletion layer, right? Only in the first case we are having this condition. In all other cases we are having Vg value greater than 0. In all other cases we are having Vg value greater than 0. In these three different cases we are having Vg value greater than 0. And depending upon the value of Vg, these three modes can happen. If the value of Vg is very less positive, then it is depletion. If you are increasing further, you will get inversion mode. And if you are further increasing, you will get the strong inversion mode. So it depends upon the value of Vg. I mean, that mode of operation depends upon the value of Vg. And we have denoted this as EIB. EIB stands for intrinsic energy level at the bulk. Bulk means inside the material. Inside the material. And this is the surface. If you are taking interface, this is actually the interface between oxide and, so this is oxide and semiconductor. So towards the interface of oxide and semiconductor, you will be having EI, which is called EIS, that is intrinsic energy level at surface. So you have intrinsic energy level at the bulk and intrinsic energy level at the surface. Okay, and we have seen the different terms also. This one, that is EIB minus EF. EIB minus EF was termed as phi F. Already പറഞ്ഞാണ്, I am just writing that again. If we are representing this in terms of energy, you can represent it as Q phi F is equal to EIB minus EF. EIB minus EF. This will be your Q phi F, and this is called the phi F is called the Fermi potential. Phi F is called Fermi potential. Okay. And another representation is this difference between the two intrinsic levels. EIB, EIS and the difference. This difference between the two intrinsic energy levels, that is EIB minus EIS, is called Q phi S, where phi S is called surface potential. Phi S is called surface potential. And finally, we have written the condition for strong inversion as, in the case of strong inversion, I mentioned that this value has to be equal to this value. Okay, that is phi F has to be half that of phi S, or you can say that phi S is equal to, or you can say that phi S is equal to 2 phi F. That is surface potential is equal to twice the Fermi potential for strong inversion to take place. So I mentioned yesterday that what is inversion? What is inversion? Usually we are expecting a p-type semiconductor over here, but when this intrinsic energy level comes below EF, what happens is we are actually getting an n-type, right? When the Fermi level, that is when the intrinsic energy level is above EF, it is actually p-type. EI nu parayunna value EF nu molalanaങ്കിൽ that is actually p-type. But when it comes down EF, it becomes n-type, or it has a tendency to become n-type, or which means that at the surface, and this process actually takes place near the surface. The process EI nu parayunna level, EI level is coming below the EF towards the surface. Surface node aduthana EI level EF nu taadu varunnu. So which means that towards the surface you have some accumulation of electrons. So which means is not actually what we expect. That's why we call it as an inversion. നമ്മൾ എക്സ്പെക്ട് ചെയ്യുന്നത് ഹോൾസ് അല്ലെങ്കിൽ പി ടൈപ്പ് ആണ്. But what is actually happening over here is we are getting an accumulation of electrons because EI is coming below EF. So this is why this mode of operation is called inversion or strong inversion. I hope that 4 modes are clear. And along with this, you will be asked to draw the equilibrium mode also. Equilibrium mode varaikkan chodikam. That you already know. You just need to align the Fermi level and the Fermi level of semiconductor and the metal. Okay, this will be the equilibrium level. Already the parnana, I am repeating this because this is very important. EFM will be the oxide level, and you have EF. This will be on the same line. Then you can form the rest of the line. That is, remaining things are, since we are considering a p-type, we will be having EV closer to this and EC above this, Okay, EC over here, and in between you'll be having EI. So this will be the case of equilibrium Mohs capacitor. In certain question papers, it is asked, sometimes it is asked like, to draw the ideal Mohs capacitor energy band diagram. Then you have to draw the equilibrium energy band diagram. If you are asked to draw the energy band diagram of ideal Mohs cap, you need to draw the equilibrium Mohs capacitor energy band diagram. Clear? Is that clear? Modes of operation clear ആണല്ലോ? And you have to write sentences for that also. If it is asked for a 10-mark question, then for the figures you will get obviously 6 marks. If you are drawing the figures alone, you will get 6 marks only. Remaining 4 marks will be for explanation. Explanation is nothing but what all things we are writing, we need to express that in terms of words. We just need to express that in words. That will be enough in the case of Mohs cap. Okay. Now we need to do some problems from the previous part, that is from the transistor part. We need to do some problems, some numerical questions. So I will just give one question. Yes. Please note down the question. The current components in a transistor. The current components in a transistor are first thing is which is given is INE. INE equals 2.72 2.712 into 10 raised to minus 6 into 10 raised to minus 6 ampere. INE is equal to 2.712 into 10 raised to minus 6 ampere. Then you are given IPE is equal to 0.678 milliampere. Then it's given INC. I hope you know the different terminologies. What is INE, what is IP and all. I hope you know that. INC. We are actually mentioning about BJT. Okay, നമ്മുടെ ട്രാൻസിസ്റ്ററിന്റെ കേസ് ആണ് പറയുന്നത്. It's not related to MOS cap. I'm just giving a problem with respect to transistor. So INC is 9.4 into 10 raised to minus 15, 10 raised to minus 15 ampere. Then you are given one more value, that is IPC. It's given as 0.6779 milliampere. So these are the different current components of a transistor which is given. Current components of a transistor. So you need to determine first one is gamma. Or you can write, you can mention the names. First one, injection efficiency, emitter injection efficiency. Emitter injection efficiency. Then we need to find base transport factor. Base transport factor. In C part, you need to determine beta value and alpha value. Alpha and beta value. So the representations go like this. This is alpha T. You need to find beta and alpha values. That I have already mentioned. ഇത് രണ്ടും current gains ആണ്. These two are current gains. This is actually common emitter current gain and this is common base current gain. You can try to do. First, you find the values of emitter injection efficiency and base transport factor, which you can find easily by using the direct expressions. Expressions under the directly use that you will get the value of emitter injection efficiency and base transport factor. You do that first. First, you need to find emitter injection efficiency, or its expression is IPE. I hope you remember. IPE divided by total emitter current, that is INE by INE plus IPE. This is actually what emitter injection efficiency means. Remember, the different currents are having different units. Okay, all the currents are not having the same unit, so you need to convert that into the common unit and then do the calculation. You convert everything into amperes and then do the calculation. You can mention the answer once you have completed. Anyone? പെട്ടെന്ന് ചെയ്തുകൂടെ? You having the calculators, right? What is the answer? What is the answer of emitter injection efficiency? Equation ഉണ്ടല്ലോ, directly ചെയ്താൽ പോരെ. You have all the values over here. ആർക്കും കിട്ടില്ലേ? നിഖിൽ, what is the value of emitter injection efficiency? 1 അല്ല, 1 it will not be correct. 1, some approximation is there. Yeah, 0.996 is correct. 0.996 ആ വാല്യൂ തന്നെ എടുക്കണം. Don't change, don't approximate that to 1. Okay, you need to yeah, okay, you need to write the exact value itself. It will be 0.996. What will be the unit? What will be the unit of this term? Whether this term will have any unit? Ampere ആണോ? ഇതിന് യൂണിറ്റ് ഉണ്ടാവോ? You are having ampere on both sides അല്ലേ? ഇത് ആക്ച്വലി ഒരു റേഷ്യോ പോലെ അല്ലേ? You are having ampere over here, you are having ampere over here. That will get cancelled, right? അല്ലേ അനുഗ്രഹ? Numeratorലും denominatorലും you are having amperes, right? So you will not be having any unit for this term. Okay, since it's a ratio of currents, you will not be having any unit. Anugrah, clear ആണോ? Okay, so this term will not be having any unit. So the answer is 0.996 when you do this. Then next also you can directly go for that. Then that is the base transport factor, which is represented as alpha t. You have the expression for that. Base transport factor is equal to, what is the expression for base transport factor? What is the expression for that? Alpha t is equal to, പെട്ടെന്ന് പറഞ്ഞേ, IPC divided by IPE. IPC divided by IPE will be the expression for alpha t, or base transport factor. Base transport factor alpha t is equal to IPC by IPE. That also you will get directly. Questions like this can be asked because നിങ്ങൾക്ക് ഈ expressions അറിയാമെങ്കിൽ sometimes it will be asked for some 3 marks question or something like that. You need to explain the term. ചിലപ്പോൾ അങ്ങനെ ചോദിക്കാം. In other cases you will be asked for doing some numericals based on the expression. So what is the value of that? IPC divided by IPE. Ensure that the units are same. Unit same ആയാൽ മതി. ഏത് യൂണിറ്റിലേക്കാണ് നിങ്ങൾ കൺവേർട്ട് ചെയ്താലും രണ്ട് സൈഡിലും അല്ലെങ്കിൽ ന്യൂമറേറ്ററിലും ഡിനോമിനേറ്ററിലും you should be having the same unit. ആണോ? അങ്ങനെയാണോ എല്ലാവർക്കും വരുന്നത്? ഒരു 4 ഡിജിറ്റ് എടുക്കാൻ പറ്റുമോ പ്രണവ്? അടുത്തൊരു ഡിജിറ്റ് കൂടെ പറഞ്ഞു. 0.9998. ഓക്കെ, 0.998. അതെടുത്ത് 0.9998 will be the value. 0.9998 will be the value. Then you are asked for alpha, right? Alpha ആണ് നിങ്ങളോട് അടുത്ത് ചോദിച്ചിരിക്കുന്നത്. Alpha is actually current gain. In which case? Alpha എന്ന് പറയുന്നത്, what is this value alpha? Alpha is current gain in which configuration? And last ദിവസം പറഞ്ഞിട്ടുണ്ടായിരുന്നു, we are having 3 different configurations like common base, common emitter and common collector, which you already know about the configurations. Alpha is actually the current gain of which configuration? ഏത് configuration current gain ആണ് alpha? Current gain means output current by input current, that's it. Alpha is the current gain of which configuration? Yes, common base. Common base configuration current gain ആണ് alpha എന്ന് പറയുന്നത്. Common base configuration, you know that I need not draw that again. So this is the emitter current IE, this is the collector current IC. So this is actually the common base configuration, right? Base will be common to both emitter and collector. So in this case, the gain is represented as alpha, or you can write the gain as output current divided by the input current. In this case, the output current is IC and the input current is IE. This is the expression for alpha. So you need to have these two values, IC by IE, in order to find alpha or common base current gain. നമ്മളോട് അടുത്ത് ചോദിച്ചിരിക്കുന്നത് ആൽഫ കണ്ടുപിടിക്കാനാണ്, and then you need to find beta. So IC by IE, you know, IE എന്ന് പറയുന്നത് നമുക്ക് എങ്ങനെ കിട്ടും? If we sum these two values, INE plus IPE, you will get IE. ഈ രണ്ട് വാല്യൂസും സം ചെയ്യുമ്പോൾ നിങ്ങൾക്ക് കിട്ടുന്നത് IE ആണ്. Both the INE and IPE, if you sum this, you will get IE. But there is a shortcut for this. This can also be represented as alpha T into gamma. That is, when you multiply the emitter injection efficiency with the base transport factor, what you are getting is alpha. When you multiply these two values, when you multiply alpha T and emitter injection efficiency gamma, you will get alpha or current gain. Okay, you just need to multiply these two values. You just need to multiply these two values in order to get alpha. So നിങ്ങൾ ഈ റൈറ്റ് ഹാൻഡ് സൈഡ് മൾട്ടിപ്ലൈ നോക്കുമ്പോൾ നിങ്ങൾക്ക് മനസ്സിലാവും IPE will get cancelled and rest or the remaining part will be IPC divided by INE plus IPE. അല്ലേ? If you are multiplying these two terms, ഈ രണ്ട് terms നിങ്ങൾ multiply ചെയ്യുകയാണെങ്കിൽ IPE will get cancelled since both they are coming in numerator and denominator. അത് cancelled out. Remaining will be IPC divided by INE plus IPE. INE by IPE is IE itself. Okay, and IPC can be approximated as IC. IPC can be approximated as IC. Clear ആണോ ഞാൻ പറഞ്ഞത്? See, നമുക്ക് ഇത് മൾട്ടിപ്ലൈ ചെയ്യുമ്പോൾ ഈ രണ്ട് ടേംസ് മൾട്ടിപ്ലൈ ചെയ്യുമ്പോൾ you will get IC by IE itself. എങ്ങനെയാണെന്ന് ചോദിച്ചാൽ if you are multiplying this term, that is IPE by INE plus IPE into this term, right? IPC by IPC by IPE. ഈ രണ്ട് ടേംസ് ക്യാൻസൽ ആവും. And remaining terms will be IPC divided by INE plus IPE. This can be approximated or taken as IE itself. And this IPC can be approximated as IC. There won't be much difference. IPC is approximately taken as IC itself. So you will get alpha directly when you multiply the base transport factor alpha T and the emitter injection efficiency gamma. So you need not do anything else. You just need to multiply this value with this value in order to get alpha. അതെങ്ങനെയാണെന്നുള്ളതാണ് ഇവിടെ പറഞ്ഞിട്ടുള്ളത്. Okay, you didn't understand, you can write this. Okay, you multiply and just tell me the answer. 0.9998 multiplied by 0.996. Yes, 0.9958. That's correct. 0.9958. Again, this also will not be having any unit since it is also a ratio. IC by IE. Random current ആണ്. So the units will get cancelled if you are considering SI units. So there won't be any unit for this since this is also a gain value or unitless quantity. Then you are asked beta, right? Beta ആണ് അടുത്ത് നിങ്ങളോട് ചോദിച്ചിരിക്കുന്നത്. So in order to find that, you will have to be aware of the relation between alpha and beta. Alpha and beta തമ്മിലുള്ള relation അറിയാമെങ്കിൽ you can directly find beta from this value itself. Anyone know the relation between alpha and beta? അറിയോ relation between alpha and beta? പഠിച്ചിട്ടുണ്ടാവും നിങ്ങൾ. If you don't know, you just see this. You will be separately knowing what is beta. Beta എന്ന് പറയുന്നത് it is actually the common emitter current gain. Common emitter current gain കേസിൽ എങ്ങനെയാണ് expression വരിക? Common base കേസിൽ expression will come like IC by IE. How will the expression change in case of common emitter? Common emitter കേസിൽ എങ്ങനെയായിരിക്കും ആവുക? Common emitter കേസിൽ output will be IC and beta will be IB. Okay. And you have the general expression IE is equal to IB plus IC. That is a transistor current equation. Transistor currents mark we studied this expression. That is IE. That is collector current is equal to base current plus collector current. Sorry, emitter current is equal to base current plus collector current. So you have these three expressions. These three expressions under. You need to find the expression for beta in terms of alpha. How will you do that? Beta in terms of alpha. You need beta in this term. Like, beta. Beta is actually IC by IB. IC by IB ആണ് beta എന്ന് പറയുന്നത്. Can anyone get the expression for beta? Beta is equal to, in terms of alpha, what is the expression for 1 minus alpha മാത്രമാണോ? Beta is equal to, ഒന്ന് ചെയ്തു നോക്കി നിങ്ങൾക്ക് കിട്ടും. I think you have already studied this in previous classes. Just try to do what is the value of beta in terms of alpha. It is actually alpha by 1 minus alpha. Alpha by 1 minus alpha. If you have doubt, you can do that separately. Okay, alpha value is IC by IE divided by 1 minus is 1 minus IC by IE. IC by IE. So if you do this, you will have IC. I will write that. So this will be further equal to, IC by IE divided by, this will be IE minus IC. If I am taking the LCM, okay, taking LCM, it will be IC by IE divided by IE minus IC by IE. This IE will be cancelled. IE minus IC will be, what is IE minus IC? IE minus IC in the, from this one, IE minus IC will be IB. So it will be IC divided by IB, which is nothing but beta. Okay, so beta can be written as alpha by 1 minus alpha. Beta can be written as alpha by 1 minus alpha. So once you get the value of alpha, you can immediately find the value of beta also. You just remember this expression. The expression if you cannot derive this. Okay, beta is equal to 1 minus alpha, alpha by 1 minus alpha. So you can do that also, since you know the value of alpha, 0.9958. Anyone? Get here. 237 will be the right answer. Beta value will be 237. 237 will be the value of beta. So questions like this can be asked. So this, in a similar way, you have written the expression for beta in terms of alpha, right? In a similar way, you can represent alpha in terms of beta also. Beta, you have represent beta in terms of alpha. In a similar manner, you can represent alpha in terms of beta. That is, alpha is equal to beta by 1 plus beta. That also you can just note 1 plus beta. Beta is alpha by 1 minus alpha. Similarly, alpha is equal to beta by 1 plus beta. These two expressions are usually been used in numericals. ഈ 237 എല്ലാവർക്കും കിട്ടിയല്ലോ അല്ലേ? Hope everyone got the value. Okay. Okay, that's it. Remaining we will see in the next class. You can mark your attendance. Thank you.